In this video, we're going to find the domain of composite functions, so like g of f of x or f of g of x, when you're putting two functions together in a composite type way. All right, and the steps to do it can be a little bit tricky. So this might not make sense quite yet, but after we do a few examples, I think that it will. All right, so I'm just going to go through our steps here, and then we're going to apply those in our next few problems. Here it says that our first step is we need to find both the domain of f and g. So our two functions that we're using, I'm just calling them f and g. Yours might be like h or something else. The second one here says we're going to exclude the inputs x, right, from the domain of g, for which g of x is not in the domain of f. That's the hard part. All right, so we're going to kind of show you what that means coming up. And then lastly, it says that this results in the domain of f of g. So with that said, let's try a few examples. All right, in our first problem, we have two functions, f of x, which is x squared plus 7, and g of x, which is the square root of x minus 3 here. All right, so if I were to find the domain, remember our first step was to find the domain of both our f and our g. F of x is going to be all real numbers. You can use that if you want to indicate, but it's just from negative infinity to positive infinity. Any number that I plug in there, if I square the x and add 7, it's going to give me an okay output. All right. However, with the square root of x minus 3, this one, remember, if it's a number that is 3 or less, that's going to give me a negative inside the square root. And if you type that in negative, the square root of something negative in your calculator, it's going to give you an error. And so therefore, that is not part of our domain. All right. So I could represent that by saying for all my x's, let's see, you could do set notation and just say that it's going to be, let's say, x such that x is greater than or equal to 3, maybe that could work. Or it would be just from 3 to infinity if you're to write it in interval notation, right? I don't care if you use set notation like that or interval notation. But either way, let's find the composition here of f of g of x and see how that affects our composition. All right, so let's go with this one. So instead of x, I'm leaving a space squared plus 7. And in that space, I'm going to put the square root of x minus 3. All right, the square and the square root cancel here, leaving me with x minus 3 plus 7. Negative 3 plus 7 is going to be 4. So I have x plus 4, which again, if that's what f of g of x looks like, throw that in parentheses, we're not dividing, there's no square roots, so it looks like there's no restriction on this if I were just to find the composition of itself and then try to find the domain. But you have to remember that, what did we input to get that? And of course, we inputted our g function into the f. All right, so by inputting that into our f function, this is going to be part of that restriction. And so therefore, that's going to be the only restriction, as both of these were all real numbers. All right, so I can say that the domain of, I'll say the domain of f of g of x here is going to be this, from positive 3 all the way to infinity. And anything in that domain will be part of my domain of the composition of the function. All right, let's try maybe a couple more and see if that can help solidify that idea. All right, here's one where our f function is going to be 3 over x and our g function is going to be 2x over 5. All right, so in either of these, is there any restrictions on our domain? Well, yeah, in the f function, if I were to find the domain of it, x can't be 0. Remember, we set the bottom equal to 0, and here if x equals 0, well, there's nothing left I can do on that, just x can't be 0. All right, so it's going to be my domain. If you want to use interval notation again, it's going to be from negative infinity till 0, union with the other side of 0 until positive infinity. Like I tell my students, it's if you were to take the whole number line, negative infinity to positive infinity, where is that breaking up at? And here it's getting broke up at 0. So again, think from negative infinity to positive infinity is broken up here at 0, where it approaches it and gets really close on either side, but at 0 itself, there is no domain there. All right, our g function, this one, 5 on the bottom. If I set 5 equal to 0, that doesn't even make sense. We cannot solve, and so therefore this is going to be all real numbers. In fact, it's going to be from negative infinity to infinity. Okay, so that said, if I were to plug in the g into the f, is there going to be any trouble there? Well, not from the g standpoint, because I'm plugging this in and there's no restriction for the g that's going to inhibit the domain of the f of g of x. However, f of g of x by itself might have some restriction on it. So let's plug that in and see what happens. So if I find f of g of x, what is this going to look like? Well, my f function is going to be 3 over, and then instead of x, I'm leaving a space, and in that space, we're plugging the g in, which is 2x over 5. Okay, I want to make this a fraction over a fraction. So instead of 3, I'm going to say 3 over 1. And then I'm going to flip and multiply here. And what happens with that, I'll say equals, is going to be 3 over 1 times 5 over 2x. 5 over, my goodness, 2x. So that gives me 15 over 2x, I think, 15 over 2x. And here, clearly, there's an x in the denominator, which is going to be problematic with our domain. And so if I set that equal to 0, 2x equals 0, and solve, of course, just divide by 2, I'm still going to have 0. X equals 0 here. So again, just like this one had an x in the bottom, this one also had just 2x, and we're going to be restricted at 0. So my domain, you could say, because this one was negative infinity to positive infinity, that's not going to affect it at all, but the f of g of x by itself is going to have a restriction on the domain. And so I can say my domain is going to be from negative infinity until 0, because that did not work, union with 0 to infinity. All right, let's try one more. All right, this last one here has the potential to be the most interesting, as they both our f of x and g of x have x's in the denominator. And so when we go to find the domain of each one individually, we're going to see that there's going to be parts that are excluded from our domain on each. For example, if I were to set the bottom equal to 0 on this one, x minus 1 equals 0. Of course, x equals 1. All right, and so that's going to be excluded from the domain of f of x. All right, which isn't necessarily important when it comes to finding the domain of f of g of x, but the domain of g of x is. All right, so here, if I take the bottom, the denominator 3x minus 2, set that equal to 0, I think we're going to get 2/3. You have to add 2 to both sides and then divide by 3. All right, divide by 3 and get, x equals 2/3. So here, my denominator, or my domain, I should say, is going to be all real numbers except for 2/3. Now, because I am inputting, I'm trying to find f of g of x, right? And I'm inputting the g of x into the f function. Automatically, if this is not part of the domain of g, it's not going to be part of the domain of f of g of x. All right, so I cannot include this in the domain of f of g of x. However, this one, it could be included in the function f of g of x, as I am inputting something besides f into my function of f, which is g of x. All right, so let's go ahead and real quick find the composition of f of g of x. And I think this one's a little bit tricky, so I'll try to do it carefully here. We have 5 over, and I'll show you a shortcut after that, 5 over x minus 1. Instead of x, remember, we're going to leave a space, and in that space, we're going to put g of x. So let me do this maybe. Leave a space here in that function, or in that space, we're going to put 4 over 3x minus 2. All right, now this gets a little bit messy down here. So let's see, instead of saying minus 1, I'm just going to say minus 3x minus 2 over 3x minus 2, as that is 1. So 5 over 4, 3x minus 2 minus 3x minus 2 over 3x minus 2. Okay, because those are common denominators now, I can add 4, or not add, but subtract 4 minus 3x minus 2. That's important to note because I'm going to be subtracting, so I have to distribute that negative in up there and get 5 over 4 minus 3x plus 2, okay, all divided by 3x minus 2. Now, our big fraction here, if you remember, is this one, or the one below the 5. If I were to make this, instead of 5 over 1, I'm going to flip and multiply this guy. And this is where it gets interesting, because now it's 5 over 1 times 3x minus 2 over 4 minus 2, or sorry, 4 plus 2 is 6 minus 3x. I'm kind of simplifying as I go here. Okay, if I want to completely simplify this, the top now is going to be 15x minus 10. Remember, this is being multiplied, so I'm just multiplying the top, and I got to multiply the bottom, and you get 6 minus 3x. All right, that was a lot. And if I look at the bottom here, I have to set that equal to 0 and solve. And then, like I said, I'm going to show you a shortcut after that, so you don't have to do all this math when you're just finding the domain. So we get 6 minus 3x equal to 0. If I add 3x plus 3x, we get 6 equals 3x, divide by 3, and 2 equals x. So my domain has to also exclude 2 from it. However, remember, why did we even find this? Why did we find x equals 1? Because I need to find values for g that when I input those values, it's going to give me 1. And because I'm doing f of g of x, I'm inputting g into the f, it can't equal 1. So the shortcut is just to take g of x, I'll do it over here, 4 over 3x minus 2, and just figure out when does that equal 1. All right, and you're going to notice that it's going to also be 2. All right, I believe. If I cross multiply here, you can see instead of 1, I'm going to make this 1 over 1, cross multiply to get 4 equals 3x minus 2. Add 2, and 6 equals 3x, and so x equals 2. To me, I'd rather do that math than find all of f of g of x and then try to exclude that from our domain. So that begs the question, what is our domain then for f of g of x? And it is going to be all real numbers except for my g, the limit on the domain of g, as well as the exclusion, I should say, of f of g of x. So from negative infinity until, which one's smaller, 2/3 or 2? 2/3 is smaller. So until 2/3, union with the other side of 2/3 until my next number, which is 2, union with 2 now until finally I can get to infinity. So again, from negative infinity to positive infinity, I'm breaking that up at 2/3, and I'm breaking it up at 2. All right, so that's quite the process to find the domain of these rational functions, but with a little bit of practice, I think you can get it.